All right, let's talk about artificial intelligence. You've probably heard the term everywhere, right? It's in your phone, it's in your car, but what is it, really? Over the next few minutes, we're going to strip away the hype and get right to the core of what AI is all about. From a simple question someone asked over 70 years ago to the tools that are literally changing our world as we speak. So let's dive in. You know, the entire massive field of artificial intelligence, everything we're about to get into, really just boils down to this one deceptively simple question. Can a machine think? It sounds basic, but that single idea has been the engine driving this whole field for decades. But, to even begin to answer that, we have to take a step back and ask something even more fundamental. What does it even mean to be intelligent in the first place? I mean, before we can even try to build a thinking machine, we kind of need a blueprint for what thinking is.
At its most basic level, this is what we're talking about. Intelligence isn't just about having a bunch of facts stored away somewhere. It's the ability to acquire new information, to learn from experience, and then, crucially, to apply that knowledge to solve problems. It's this constant loop of learning and doing.
And this brings us to one of the giants of the field, the brilliant computer scientist Alan Turing. Back in 1950, instead of getting bogged down in endless philosophical debates, he decided to make it practical. He proposed a test, really, it's more of a game, to see if a machine could behave in a way that's totally indistinguishable from a human.
So here's how his imitation game works. Picture this, you're an interrogator. You're just sitting there, typing questions into a screen. You're talking to two players, but you can't see them. One of them is a person, the other is a computer. And the computer's only goal is to fool you, to convince you that it's the human. If it can pull that off, it passes the test. And notice the key thing here. This isn't about proving a machine is conscious or has feelings. Not at all. It's purely about performance. Can it imitate human intelligence so well that we can't tell the difference?
Okay, so the Turing test gives us a great philosophical benchmark. But how do we get from a thought experiment to a real-world tool that can actually, do things? Well, it all starts with this one core idea, the intelligent agent.
The whole concept is a really simple but powerful loop. First off, an agent has to be able to perceive its environment. It uses what we call sensors, like our eyes and ears, or a robot's camera, to take in information about the world around it. But just seeing the world isn't enough, right? After it perceives something, it needs to be able to act on that information. It uses actuators, things like our hands, or a robot's motors, or even just a piece of code that sends a file, to actually make a change in its environment. It's this constant cycle: sense, think, act. And what's really cool is how broad this definition is. Think about it. You are an intelligent agent. Your sensors are your eyes and ears, and your actuators are your hands and legs. A robot, obviously, is an agent with its cameras and motors, but even a piece of software can be an agent. That spam filter in your email? Yep, that's an agent. It senses an incoming email and acts by moving it to the junk folder.
So this is the million-dollar question, isn't it? It's one thing to be able to see and do things, but the intelligence? Well, that's what happens in the middle. Out of all the possible things it could do, how does an agent choose the right action?
One of the most fundamental ways an AI agent makes a decision is by treating the problem like it's a puzzle. It basically looks at all the possible moves and tries to find the very best path to get to the solution.
The way it does this is by creating something called a state space. The best way to think about it is like a giant map. Every single point on that map represents one possible state the puzzle can be in. The starting point is on one side, the goal is on the other, and the AI's job is to explore all the connecting roads to find the most efficient route from start to finish. This classic water jug problem shows it perfectly. So the goal is to get exactly 1 gallon. The AI starts at an initial state, then it tries an action, like, I'll empty the big jug. Boom. That moves it to a new state on our map. Then it keeps trying different moves, filling, pouring from one to the other, and each move creates a new branching path. It just keeps exploring until it finally finds the sequence that leads to the goal. Okay, so we've got this foundation of agents solving problems. Now, let's connect that to the terms you hear all the time: artificial intelligence, machine learning, and deep learning. What is the actual difference? So, artificial intelligence, or AI, that's the big one. It's the whole umbrella. It's the entire field dedicated to this grand idea of creating machines that can do smart stuff. It's the whole forest. Now, machine learning, or ML, is a subset of AI. It's a specific way of achieving AI. Instead of a programmer having to write explicit rules for every single possibility, with ML, we just feed the system a ton of data and let it learn the patterns for itself. So if AI is the forest, machine learning is a specific type of tree in that forest.
And then deep learning is a subset of machine learning. It's a more advanced technique that uses complex structures called neural networks, which are kind of inspired by the human brain. This lets it find incredibly complex patterns and, most importantly, allows it to learn from its own mistakes. To finish the analogy, AI is the forest, ML is a tree, and deep learning is a powerful branch on that tree.
So the really crucial difference is the goal. AI is the broad, ambitious goal to create intelligence. Machine learning is a practical tool that focuses on a much narrower goal. Just take a bunch of data and get really accurate at performing one specific task, whether that's spotting spam or recognizing a face.
So we have the big idea of AI, and we have the powerful tool of machine learning. Let's make this real. Where are these intelligent agents actually showing up in our world today? Well, the answer is pretty much everywhere.
Seriously, think about the recommendation engine on Netflix or YouTube. That's an agent. It senses your viewing history, it thinks by comparing you to millions of others, and it acts by showing you a new suggestion. We see this same loop all over the place, from search engines and spam filters to the incredibly complex systems in a self-driving car, and even in medical tools that help doctors diagnose diseases. And this brings us right to the edge of the future. See, most of the AI we have today is called narrow AI. It's really good at one specific thing. But the long-term goal for many researchers is general AI. That's a system that wouldn't just be good at one task, but could potentially outperform humans at any cognitive task you could throw at it.
Of course, this incredible potential also raises some very profound questions and some serious risks. As these systems become more powerful and more autonomous, the consequences of a mistake or a poorly defined goal just get higher and higher. It means we have to think very carefully about the safeguards.
And so we kind of end where we began. We started by asking, can a machine think? And we've gone from a simple imitation game to systems that could, one day, redefine intelligence itself. This isn't science fiction anymore. The question is shifting from if machines will outthink us to when, and how we're going to navigate that new world. It leaves us with a final thought. Are we ready for what comes next?